Yeah. Good evening, everyone. Welcome to tonight's webinar. Thank you for joining. It's very cold. I hope you have some coffee. Today we have a very special presentation with a main presenter and then a few guest presenters who will join in throughout the presentation. So I have the privilege to introduce our main presenter today, Miss Elmarie Davoren, and I always struggle with your surname after all these years. So Elmarie Davoren is a principal investigator at the Center for Human Metabolomics at the Northwest University on the Potchefstroom campus. Since 2021, she has been working as a scientist in the research and development team and is responsible for method development, validation for diagnostic and research purposes, and she focuses on small molecule analysis. Her responsibilities include, amongst others, customer engagement, research and project design, method development and validation, sample analysis, data processing, and staff training. She holds a MSc in biochemistry, which she received from the Northwest University together with all her other degrees. And she has extensive training in lab quality management, mass spectrometry, and project management. So it says that you've been here since 2021, but I think that's a lie. That's just your current role.
Yes.
I think you've been here since 10 years before.
Yeah.
Yes. So thank you, Elmarie. Tonight's topic is a general overview of the available online resources when dealing with a patient with a suspected or a confirmed inborn metabolic disease. Thank you very much, Elmarie. You can just, after the webinar, you can just paste your questions in the Q&A or in the chat function, and we will read them aloud. You can address the question either to Elmarie or any one of the guest speakers. You're actually welcome to post the question during the talk as well, and we will just read it after the talk. Thank you very much, Elmarie. And then a big thank you and a shout out to Pfizer, who is the sponsor of this event. And I just want to say that Pfizer has absolutely no influence on the talk tonight. They didn't choose the topics, and they didn't prescribe any of the speakers on what they have to say. Thank you very much, Elmarie. Good luck, and enjoy the talk.
Okay, thank you, Ilse. Okay, so good evening, ladies and gentlemen. So as Ilse mentioned, my presentation will be a general overview of available online resources when dealing with a patient with a suspected or confirmed inborn metabolic disease. So just a little bit of a background. So inherited metabolic disorders are a complex and heterogeneous group of monogenic disorders. They usually result from deficient activity in a single pathway of intermediary metabolism. And recognizing individuals with inherited diseases can be difficult because the signs and symptoms often overlap with those of common medical conditions. So the most recent nosology of IMDs include well over 1,000 disorders. And then even though they are individually rare, their collective prevalence is estimated at greater than 1 in 8,000 individuals. So identification of rare genetic disorders has been greatly improved by the advent of genome-wide sequencing. And so it has not only expanded our knowledge of rare disease genetics, but also enhanced our ability to diagnose new patients. So however, the diagnosis of rare genetic disorders still remain challenging because patients are misdiagnosed and diagnosis is delayed because of the non-specificity and heterogeneity of the signs and symptoms, the rarity of the conditions, as well as limited access to the knowledge of highly specialized experts. So what can we do when an IMD is suspected, or what resources are available to aid clinicians in diagnosing these patients? So for the purposes of this presentation, I will focus on the following resources. So the general resources are Metabolomics, IEM-based and RareMD, whereas treatable ID and face-to-gene are more specific resources. So the objective of Metabolomics is to provide a systematic and practical approach to the diagnosis of metabolic diseases. It explains the typical presentation patterns of the various metabolic disease groups. It describes essential differential diagnostic procedures, and it also summarizes the main features of the diseases from the clinician's point of view. So this is how it looks when it is accessed on the internet. So unfortunately, you cannot download it on Google Play or the App Store. And this online resource is also based on information that was published in 2011 on the printed version of this resource. So a fifth edition has recently been published in 2021, which has been updated with new disorders and a more modern look of the metabolic pathways. So once you have selected the main menu button, the information is grouped according to the following sections: emergency information, metabolic pathways and disorders, basic laboratory tests, general clinical situations, special metabolic investigations, function tests, and newborn screening. So I will show you an example of each section and what information is available. So if you select the first section, namely emergency information, it will give you the following options. Patterns of acute presentation include the metabolic emergency, early onset seizure, cardiomyopathy, liver failure, SIDS, and postmortem investigations, whereas important laboratory findings refer to general clinical situations, specifically hypoglycemia, hyperammonemia, metabolic acidosis, and elevated lactate. In the emergency information section, a list is given of medications that should be available in most intensive care units that can be given to patients in emergency situations. The recommended dosages are also given. So if the metabolic emergency option is selected, general information is given with regard to how metabolic disorders or metabolic decompensation presents in the neonatal period, as well as after the neonatal period. So, however, metabolic disorders should always be considered in all neonates presenting with an unexplained or progressive disease, in all children with acute deterioration, particularly if this is preceded by vomiting, fever, or fasting, and in all children presenting with acidosis or hypoglycemia. So as part of this section, the emergency investigations and first-line management is also discussed. It specifies which routine biochemical investigations should be performed as soon as possible, what type of samples will be needed for more specialized metabolic testing, and this includes for amino acids, acylcarnitines, and organic acids. Next, the treatment and relevant investigations to be done are also specified, which would depend on what the emergency investigation showed. It also specifies what should be done if the results of the emergency investigations are inconclusive and a metabolic disease is still a possibility. So 15 metabolic pathways and their associated disorders are also discussed. As you can see, it is quite comprehensive as it includes disorders of small molecules, complex molecules, as well as energy utilization and production. If you select a specific metabolic pathway, in this case, amino acids and peptides, it gives you a short overview of the disorders. So amino acid disorders result in the accumulation of toxic substances that causing organ damage. And this is mainly due to deficiencies of the cytosolic enzymes. So whereas organic aciduria usually disturb energy metabolism and leads to lactic acidosis. The typical presentation and age of presentation is discussed. These disorders usually present with acute coma, ataxia, or encephalopathy without evidence of encephalitis. Acute unclear deterioration or prolonged disease course of a non-specific infection, progressive neurological symptoms. There is also unexplained acidosis. Patients present with hyperammonemia. So the previous section can be utilized when an IMD is suspected, whereas the principles of treatment is specifically for when a diagnosis has been confirmed. It also diverts you to the management of children presenting with metabolic decompensation of unknown cause, as well as the emergency treatment of hyperammonemia sections. These disorders are treated mainly by restricting protein intake, and depending on the disorder, specific detoxifying drugs, vitamins, and cofactors can be given. Patients on protein-restricted diets should be monitored regularly via routine laboratory tests, as well as specialized metabolic tests, in case a treatment plan has to be adjusted. It also gives you a summary of how patients can be treated at home during intercurrent illness. This usually involves the following. Protein intake should be stopped. Sufficient fluid and calories should be given every 2 hours according to the table on the screen. It also states when protein can be added and at what amount. However, if vomiting persists or fluid and dextrose intake remain poor, patients should be hospitalized immediately. The emergency treatment plan in hospital is also discussed for patients when acute decompensation is a possibility. Here it specifies the tests that should be done, the medication to be given, as well as specific drug treatments that can be considered based on the disease and the laboratory findings. The third section discusses essential basic laboratory tests that should and can be performed. I selected ammonia since hyperammonemia is associated with urea cycle disorders and organic acid disorders. So general information is given with regard to normal and abnormal values for ammonia in the neonatal and postneonatal period. Information is also given on how the sample should be taken and stored. So a metabolic disorder should always be suspected in term babies with an ammonia level more than 200 micromolar. Diagnosis should be confirmed as soon as possible since the treatment is dependent on a specific cause of hyperammonemia. And the most common causes associated with hyperammonemia is also listed. So in the case of AMDs, it is usually urea cycle disorders, organic acidureas, and long-chain fatty acid oxidation defects. So a table is also given indicating how these disorders can be diagnosed. For example, if citrulline is low in plasma and orotic acid is elevated, then it is most likely an ornithine transcarbamylase deficiency. But when citrulline is above 50 micromolar, the orotic acid is decreased to normal and the lactate is elevated, it is then most likely a pyruvate carboxylase deficiency in the neonatal period. So once hyperammonemia has been confirmed, emergency treatment can be carried out and the steps for treatment is also discussed. So the next section describes general clinical situations that are associated with IMDs. These clinical situations include metabolic encephalopathy, exercise intolerance, cardiomyopathy, liver disease, as well as dysmorphic features. As you can see, the clinical situations are relatively broad, which is expected as IMDs present as complicated medical conditions that involve several organ systems. So for the purposes of today's presentation, I will use the floppy infant as an example. General information is given stating that muscular hypertonia is a common symptom in IMDs. It is usually associated with lethargy or coma, neurological abnormalities, and seizures. However, primary neuromuscular disorders or Prader-Willi syndrome should be expected in cases of isolated muscular hypertonia. A list is also given on the basic laboratory investigations that should be performed, including the specialized metabolic tests that can be done, for example, urinary organic acids and oligosaccharides, acylcarnitines on serum. Conditions associated with muscular hypertonia include mitochondrial disorders, fatty acid oxidation disorders, Pompe disease, and peroxisomal disorders. Next to each disorder, a link is also given, which will then divert you to the relevant information pertaining to that specific disorder or group of disorders. So in the section pertaining to special metabolic investigations, a list is given of the various tests that can be performed to confirm diagnosis of a suspected IMD. These tests range from simple metabolic urine tests, which include lab sticks and reducing substances, to more specialized tests such as enzyme studies and biopsies, as well as molecular genetic investigations. So I will show you the section on amino acids since it was discussed in previous slides. So amino acids can be analyzed via an amino acid analyzer, GCMS and LCMS. Serum or plasma is the preferred sample type for the analysis. And CSF is only required when a specific amino acid disorder is suspected, such as non-ketotic hyperglycemia. This section also specifies how these samples should be handled prior to analysis. But always contact your local laboratory where these analyses will be performed, as their protocol with regard to sample type and handling might differ. For example, our laboratory's protocol specifically states that no preservatives should be added to urine samples. So after the samples have been analyzed and the results have been received, specific amino acid findings are listed that can aid in diagnosis. For example, if isoleucine is below 25 micromolar, a protein deficiency should be considered. A disturbance in the energy metabolism should be considered if alanine and proline is elevated and the alanine to lysine ratio is more than 3. This finding can also be substantiated by elevated pyruvate. When interpreting amino acid results, please keep in mind that values depend on the metabolic state of the patient. For example, branched-chain amino acids will be elevated after prolonged fasting, whereas the other amino acids will be decreased. Results will also be influenced by sample handling and shipping conditions. So if samples are hemolyzed, arginine, glutamine, asparagine, and cysteine will be decreased, and aspartic acid, glutamic acid, ornithine, phenylalanine, tyrosine, and taurine will be increased. The second to last section discusses various function tests that can be performed when a specific IMD is suspected. So this must be done in a controlled environment to show if and how a patient responds abnormally to a specific metabolic challenge. Once you have selected a specific function test, information is given with regard to the procedure, the specific clinical indications that should be present prior to administering the test, as well as a section on the interpretation of the results. However, due to the advances in enzymatic and molecular diagnostics, diagnosis can usually be confirmed without function tests. So newborn screening is the last section, but certainly not the least important section that will be discussed. So here general information is given about newborn screening. It is also subdivided according to disorders associated with IEMs and non-metabolic disorders. The newborn screening panel differs between countries and laboratories. So for example, our laboratory screens for 22 conditions. This section also refers you to additional guidelines and fact sheets that can aid a clinician as soon as a positive newborn screening result has been received. So the next online resource that will be discussed is IEM base. It is an online application that combines the IEM community's knowledge base with a prototype mini expert system. So the expert compiled knowledge base provides clinical, biochemical, and genetic profiles of more than 500 known IEMs. In short, the mini expert system accepts a list of biochemical and clinical phenotypes from users. It then compares the input phenotypic profile against a profile against IMDs in the knowledge base and returns a list of matching IMDs diagnoses. IMD diagnoses. With the resulting list, users can then generate differential diagnosis charts, biochemical test panels, and targeted gene panels. So the clinician can then pursue biochemical and genetic investigations concurrently for rapid diagnosis. So it can be accessed online, but also can be downloaded via Google Play or the App Store. And this is what it looks like when you access it via the web. On the left-hand side is a list of diseases that have been added to the website. And this is done, it's continuously being, new diseases are being added to the website. And then on the right-hand side, you can click on a tutorial video about how to use the mini expert search tool. So I will play the tutorial video a little bit later in the presentation. Okay, so once you have clicked on the magnifier glass, you can then start searching IEM base, which will take you then to the main search page. At the main search page, you can then search for either disorders, genes, or symptoms. So if you click on the browse option located on the top of the screen, a list of disorder groups are given. You can then select a specific metabolic pathway, which is also associated with that disorder group. If you are interested in a specific group of disorders, you can select the relevant metabolic pathways, as well as get a list of the various disorders that are associated with that pathway. So, for example, I selected isovaleric acidemia, and then it will give you information with regard to the prevalence, the mode of inheritance, and if it is treatable or not. The clinical symptoms that are characteristic with IBA is also highlighted. So this table also groups it according to how the disorder will present for different age groups. The biochemical markers that are associated with IBA is also tabulated. And then the highlighted rows will indicate the most relevant markers. The table is also grouped according to how the biochemical markers might differ depending on the age of the patient. The table also gives you information pertaining to what enzymes should be tested to confirm the diagnosis. A list is also given with the routine tests that can be performed and whether the test will be elevated, normal, or decreased. For example, the anion gap will be increased for all age groups, but glucose will either be normal or low. The relevant genetic information is also given stating the protein name, the chromosomal location, as well as the NCBI gene number. You can also click on the blue highlighted text, which will then divert you to the additional information that's specific to those genetic registries. For example, KEK, UniProt, and NCBI. So I'm going to play the tutorial video of the mini expert search tool. Hopefully everything goes well.
The Inborn Errors of Metabolism Knowledge Base, IEM Base, is a resource dedicated to consolidating knowledge and raising clinical awareness of inborn errors of metabolism, rare genetic conditions usually presenting in childhood. You can browse IEM Base or use its powerful search tool, the Mini Expert, which can help to identify conditions based on a patient's symptoms and biochemical test results. To access the Mini Expert tool, go to the IEM Base homepage at iembase.org. Review and agree to the terms of the disclaimer. Here, you can choose to browse the database, perform a basic search for a specific condition, or use the Mini Expert search function. By clicking on the Mini Expert option, you will arrive at the input profile page. The following case study will show you how to use the available features. A 1-year-old patient has presented to the clinic with the following symptoms: hypotonia, developmental delay, ocular gyrate crises, nasal congestion, temperature instability, and hypersalivation. To search for a symptom, start typing and then select the most appropriate option from the suggestions. Click Add to include this in the patient's profile. This step can be repeated to add more symptoms. Results from a patient's biochemical tests. In this case, a cerebrospinal fluid metabolites panel can also be included in the search. Again, start typing in a biochemical marker and select the most appropriate option, ensuring that you have chosen the correct sample source. Once you have added a marker, select whether the result was above, below, or within the normal parameters. Repeat this step to add additional biochemical results to the profile. Once the clinical signs and biochemical results have been added, click Match to run the search. You can select the Relaxed Search Criteria option to include all sample types for the biochemical tests. A ranked list will be generated, indicating conditions most closely matching the input profile. Click the Info button on each row to find out more about the selected disorder. Using our case study as an example, the results suggested that the patient may have aromatic amino acid decarboxylase, or AADC deficiency, which was later confirmed with a clinical diagnosis. The DDX tab allows you to generate differential diagnosis tables to compare clinical symptoms and biochemical findings across conditions. Select 2 or more disorders using the checkboxes and click the differential diagnosis button to produce a chart. Use the table dropdown to select whether to see only indicators with data in all the selected conditions or every indicator. Use the Onset dropdown to filter by age of presentation. Using our case study as an example, we see that patients with AADC deficiency are more likely to present decreased levels of HbA and 5-HIAA in infancy and childhood than patients with monoamine oxidase A deficiency. The biochemical tests can help with your diagnosis by listing tests that could differentiate between disorders. Again, select 2 or more disorders and click Biochemical Tests to generate an alphabetical list of assays that could help to confirm a diagnosis. Finally, the Gene Panel tab shows the genetic involvement in each disorder. Select 2 or more conditions and click Gene Panel to show the genes associated with each disorder, their chromosomal locations, which proteins they code for, and to find links to their pages in gene registries. In our example, this page tells us that mutations in the DDC gene which codes for the AADC enzyme and known to cause AADC deficiency, and provides 5 external links to follow for further information. IEMbase is an evolving resource, and its development is informed by recommendations from users. Please feel free to submit suggestions for how the site could be improved, including reporting unlisted disorders using the feedback button in the menu bar. Please note that IEMbase is not an exhaustive resource and should only be used to inform clinical testing and diagnostic procedures. We hope that you found this video useful and that you enjoy using IEMbase in the future.
Okay, so as you can see, it's quite a nice tool that can help you in diagnosing a patient.
The inborn errors of metabolism.
Okay, so the third resource that I will be discussing is Treatable ID. So this resource was created to aid in diagnosis of metabolic disorders that are associated with intellectual disability as the main symptom. So in short, intellectual disability is a condition characterized by significant limitations in cognitive function and adaptive skills, and it affects 1 to 3% of the global population. So it also often co-occurs with behavioral problems, epilepsy, and other neurological problems or disabilities. And then the cause of intellectual disability is diverse and can occur at any time from fetal development to late in life. Genetic causes are also significant and varied, and it requires extensive testing and specialist involvement. So as of 2021, 116 treatable IEMDs associated with intellectual disability have been characterized. So this is how the resource looks online. Unfortunately, you cannot access the resource on Google Play or the App Store anymore. On the website, information is presented in several different ways, which range from biochemical categories, signs and symptoms, to diagnostic tests and genes. And then for each condition, a disease page has been created, which has access to specific genetics, biochemistry, phenotype, diagnostic tests, as well as therapeutic options. So once you select the Start Here button, the website takes you to the main categories page, and then there are 18 categories listed, which includes various metabolic pathways and disorders. If you select a specific metabolic pathway, in this case, amino acid metabolism, the specific amino acid disorders that are associated with intellectual disability are given. So I selected 3-hydroxy isobutyryl coenzyme A hydrolase deficiency as an example. There you will get a short description of the disorder. There's also a view image button, which will then take you to the metabolic pathway. It shows that this disorder can be confirmed by molecular testing as well as urinary organic acid analysis. They also list the neurological and non-neurological symptoms that are associated with the disease. They also give you treatment options, specifically Valine is restricted, and then this leads to the improvement in the psychomotor development. If you select the signs and symptoms option, symptoms are grouped according to neurological and non-neurological presentation. So neurological symptoms include ataxia, epilepsy, neuropathy, vision loss, and stroke, whereas non-neurological symptoms refer to growth and stature, specific organs, and immunology. If you select the diagnosis button, or diagnosis option, the various metabolic tests are also listed, including molecular testing, enzymatic testing, then testing that can be done on plasma, urine, or CSF. There are also numerous treatment options that are given, which varies from nutritional therapy, vitamin and trace element, enzyme replacement therapy, stem cell transplant, organ transplantation, as well as gene-based therapy. If you want to use this resource, I would recommend that users read the FAQ section, which is found on the homepage of the website, as it discusses what intellectual disability is, its frequency and causes, and it also includes a nice diagnostic flowchart that can be used to diagnose patients that present with intellectual disability as its main symptom. So Face2Gene has been mentioned in previous presentations. So what it is an AI-driven tool that leverages various algorithms to analyze diagnosed patients' photos and suggest likely phenotypic traits and genes, which then can aid in feature annotation and syndrome prioritization. It can also provide you access to a database of phenotypic and genotypic data for more than 10,000 diseases, and this is sourced from real-world patient cases. So before you can use Face2Gene, you will need to register and create an account. You can register via the Face2Gene register page, or you can download it from Google Play or the App Store. The company then reviews all registrations to ensure that it is used exclusively by healthcare professionals. After confirmation, you can then upload your suspected cases to your account. So on the website, a step-by-step guide is given on how to use the clinic feature of the tool. So in short, a clinician inputs a patient photo, the technology converts it into de-identified mathematical facial descriptors, which is then compared to syndrome gestalts and then to quantify the similarity to them. This results in a prioritized list of syndromes with similar morphology. So measurements are added, specifically the patient's age, gender, ethnicity, and growth measurements, whereupon then anthropometric growth charts are automatically generated. The tool will then suggest likely phenotypic traits that the user can select. The user can also add the traits manually, and then an updated list of the suggested syndromes are generated. You can then compare your patient's face to the facial models of well-matched syndromes using the visualization tools. The user can then review and evaluate the syndromes and their associated genes. And then what's also nice is you can have the option of sharing your case with your clinical team. So it also has a list of publications, which are listed on the website about research that make use of the tool. You can sort it according to the year, the syndrome, type of algorithm that they use, as well as the geolocation, and which is what I did as an example to show the research that was done in Africa. So, okay, the last resource that I'm going to discuss tonight is RareMD. So RareMD was established in 2016, and various clinical experts, patients, and industry leaders assisted with the development of two tools, specifically RareMDx and RareLook. So RareMDx is a human intelligence-driven differential diagnosis tool that was developed for medical professionals, whereas RareLook was developed for patients, parents, and caregivers. So I will discuss RareLook first. The aim is to provide easily understandable information about undiagnosed medical conditions to patients and caregivers, so as to empower them to collaborate with the treating physicians in finding a diagnosis more efficiently. So this resource is also free of charge, but patients have to create an account by visiting the RareLook page and completing the sign-up form. Patients can then access the tool and select signs and symptoms. They can then share their search results with their treating physicians by means of a letter, which is automatically generated on the platform. The physician can then redeem the code that was included in the letter and obtain free access to RareMDx for 6 months. And then the physician can use the data from medical records to refine the search results and hopefully diagnose the patient. So where RareMDx provides medical professionals access to human intelligence-based research database, which contains more than 6,900 signs and symptoms, and they were meticulously weighted based on its relevant to more than 3,700 rare diseases that are contained in the database. Basically, users select signs and symptoms. The tool activates its probability algorithms, and a list is generated of suspected diagnoses for up to 10 rare diseases, and they are then ranked in order of probability. So I am not going to go into much detail on RareMDx, since I have asked Prof. Chris Foster, who makes use of the tool, to give us a short demonstration on how it works. Prof, do you want to take it away?
Yeah, thank you, Elmarie. Let me just share my screen. Right, so Elmarie gave me a very large chocolate to do this. I'm very happy to help. Before I start, let me just say a few things with regards to my own experience and how I see this could evolve. The first thing is, in my own experience, the program is simple and effective. It is also for all rare diseases, not just inherited metabolic diseases like the previous program that Elmarie showed. Now, I quite like iron-based as well, but the problem is, of course, that the clinician doesn't necessarily know whether he's dealing with an inherited metabolic disease or just a rare disease. So I think it's helpful to actually have all the rare diseases in one place. It's not an open platform, but we are currently negotiating with the developers to provide all UNGWE members with free membership. And if you don't know what UNGWE is, then you really should find out. So maybe Ilse, if you can just type the link in the chat section, then people can have a look at that. The other thing is that I think is very important is we have access to the developers. And if the UNGWE community utilizes this and we find that there are areas where it's inaccurate, we can rapidly inform the developers and they can then update the program, and it will enable us to make a diagnosis faster. So good news is that the CEO and founder of Rare MD is actually in the audience. And at the end, if you'd like to ask some questions, then we can make him a panelist and you can actually ask the questions to him directly. His name is Dick Meyer. He's also collaborated with Chris Hendricks on this, which I think people know well. So that also gives some additional credibility to the program. And then Elmarie has already discussed Rare MD and Rare Look. So we recently encountered a case in our laboratory, which we have never diagnosed before. We have some experience with it because we have received it, examples of it through our proficiency testing program, but this is the first time that we've diagnosed it. And I thought I'd take this case and run it through Rare MDX, and we will see what we will find. Maybe if you know what the diagnosis is, then you can type it in the chat section. And then, if you're first to make the correct diagnosis, then I don't know, maybe Ilse can send you a chocolate or something along that line. But let's just see how it goes. So it's very intuitive. So I'm just going to start with typing in some symptoms. You need to type in at least 4. And I'm going to start with fairly specific symptoms. So my own experience with using these programs is that, start with those clinical findings that you would regard as more specific, but also don't be too specific, particularly if you do it in the laboratory space. So, because, sometimes a clinician may be very specific about a particular epilepsy, but it's not correct. So I like to start off with something like epilepsy and then later go into a more specific epilepsy. But in this case, I'm going to enter cause, and you'll see as I start to type, it will start to show options that I can select. And if I wanted to be very specific, and not just give me synonyms, then I can put a semicolon. And then it's going to give me more specific symptoms. So you can see here, cause facial features. So I'm going to select that as one option. And if you've been attending our talks, you should be alert now. I'm also going to enter this osteosis multiplex. Must have made a spelling mistake somewhere. Oh, sorry. Let's just try again. Okay, and again, you can be more specific by adding the semicolon or remain with the synonyms. So I'm going to select this osteosis multiplex. Then I'm going to enter hepatos. Okay. And there it is. You see, it also gives me some other synonyms that it regards as important. So I'm going to select that. And then for now, I think I'm just going to copy and paste this because otherwise I may make some more spelling mistakes. So let's just also enter bilateral sensorineural hearing impairment. I'm going to select that. And you can see now that it has now started to give me a differential diagnosis, and it gives me some options as to what this may be. So at this point in time, you may also want to add your diagnosis in the chat section if you want to compete for that chocolate. So one more feature that I'm going to add is this patient also had immunodeficiency. Okay, I'm going to be specific about it, but not too specific. So you can see a cellular immunodeficiency combined and so on. At this stage, I'm just going to go with immunodeficiency. I can always later be more specific. And our list has now changed. Now, in this particular instance, we've done a lot of presentations on the mucopolysaccharidosis. And we actually did the glycosaminoglycans on this patient, and it came back normal. And maybe this is just a side note. So the clinician here provided us with very good clinical details. So I could see that the clinician was looking for a mucopolysaccharidosis, but it wasn't that. And that just alerted me to the fact that we should perhaps search a little bit further. So we added the oligosaccharide analysis. And if we then add oligosaccharides here, so oligosacchariduria. And if we now go to the differential diagnosis, then the diagnosis comes up right at top, alpha-monoacidosis. So there was the first case of alpha-monoacidosis diagnosed in our laboratory. But I must also say that the program also gives very appropriate other differentials, like, for example, GM1 gangliosidosis is certainly also a consideration here. So generally speaking, I find the program to be very useful. I would certainly like the Inwe community to try it out. And like I say, Dick Meyer is in the audience to answer some questions afterwards. Elmarie, over to you.
Sorry, everyone. Just want to share my screen. Okay. So basically, in summary, online resources facilitate early recognition and diagnosis of genetic disorders. They are crucial for effective treatment. These resources can be used not only by students, not only by experienced clinicians or researchers, but also by students and laboratory personnel. And with continuous updates and innovations and in artificial intelligence and data integration, I believe that we will see ongoing improvements in diagnostic capabilities. So that's my references that I use for the presentation, as well as the websites themselves. And then any questions?
Thank you very much, Elmarie. We already have questions. Just on a side note, Chris, we had one guess at least from Dr. Tirona Naika, who said MPS 2, but she did that before you said add the oligosaccharides.
Good guess, Tirona.
Then there's an anonymous attendee, and afterwards it says Rudolf van Wyk with the exact same question. Once a diagnosis is confirmed, once a diagnosis is confirmed, for example, a mitochondrial dysfunction, how is it treated? And I guess this question is about, is there any online resources that can tell you how to do the treatment? I think you got to that a bit later, but you can jump in there, Elmarie.
Well, it depends on, do we know what type of mitochondrial disorder?
Yeah, I think the question is just, for example, a mitochondrial dysfunction. How do you, is there any resources to help you with the treatment strategies, or how is it treated?
I usually go to literature.
Okay, yeah, I guess the treatment is a bit beyond the scope of us, and it's more the clinician or the physician, this would be in the hands of the treating physician or the, what do you call that? the doctor that
Mm.
treated the patient initially. Chris, did you want to jump in there? We have another question.
Yeah, just briefly. I mean, what's very important is to make a diagnosis, specific diagnosis up to genetic level, because, that really dictates treatment and what can expect from the treatment. If you have a high index of suspicion that you're dealing, for example, with mitochondrial disorder, but you haven't made the diagnosis, then there is more general support or general mitochondrial support that you can give. But certainly, it's a lot more informative to have a diagnosis. And then in many cases, there are international guidelines on how to treat the diseases. And in some instances, there are also South African or African guidelines that can be accessed.
Yes, so let me just see. Yeah, Prof. Chris Hendricks. Sorry, I can't see that name. Yes, says patients are more individuals and treatment should be personalized. Okay, sorry, that was Alma.
Mm.
So the treatment should be personalized for each patient. It's not necessarily that you will treat all patients with the defect in exactly the same way. Then Dr. Tumelu Satekhe is saying, great presentation, Elmarie. I agree. The resources look impressive because of the coverage of confirmatory genetic testing. Did you come across tools that share the common variants to look out for in different populations?
This is a Prof. Chris answer because it sounds
This
more
is a
genetic.
answer.
Sorry, Prof.
No. Yeah, literature, of course, you can get common variants in literature often. They're not always appropriate for Africa. Again, this is where the UNGWE initiative is really important because, if we can consolidate all the genetic testing, we're going to be it's going to be very easy to determine what are the common variants in South Africa and Africa, and if there are any. Sometimes there aren't. But I'm not aware of a resource that can easily give you the common variants. I mean, if you go into the genetic resources, I suppose you can kind of deduct it because sometimes it will give you frequencies and so on. But no, literature is where we mostly find the common variants, not always applicable to our scenario.
So Sibongile Mbata is making a very good comment there, saying, thank you for a very great presentation. I find that phase 2 gene struggles with African patients.
Yes.
Yes.
So that adds to that. Yeah,
Extra-
also know that there's a big need for this. So we've had a lot of collaborators and asking us to assist them to find these variants and to find the specific incidents in our population of certain genetic disorders. So that's a big need currently in the world. Lisa Boshoff is saying, how sensitive is phase 2 gene platform in the recognition of facial dysmorphology in neonatal patients?
Maybe we can ask the audience if there's somebody that has used phase 2 gene in neonates, because we haven't used it, obviously.
Just put up your hand and I can allow you to speak. I've also since promoted a few other people to panelists if they wanted to speak. Yes. Prof. Hendricks, you are on.
Yeah, can you hear me?
Yes.
Yeah, so my experience is that phase 2 gene works mostly very well with patients which are older, especially the first 6 to 8 weeks of life in the neonates. The facial features changes so significantly and so quickly, especially because of the change of the head shape and the growth, that it's not very accurate for using that. So from that perspective, I think as an identified tool, not that good. And the other comment that somebody else made, very true. It struggles with our African patients just because the algorithms are built mostly on people which are from European or Caucasian backgrounds. And I think that's one of the other things we need to address. We need to try and get our phenotypes into these tools as well and make sure they can capture them.
I don't see any further questions from
Ilse,
the audience. Yes,
there's something that I actually forgot to show about Rare MD. So could I quickly show some additional features?
yes. I
Seeing
just
that there's no more
actually wanted to
questions.
throw this question to Dick as well, who's also been promoted to a panelist now, and ask the question about the different, rare MD in the different populations and the effect that that has on the differential diagnosis. But you can continue, Chris.
Yeah, I just quickly want to show this. Somehow I forgot to show it. Sorry, let me just get rid of these pop-ups. Oops. Oh. Let me just move this slightly. Does it show the Rare MD screen?
Yes.
Can you see it?
We
Yes.
don't
Okay.
see your pop-ups.
Yeah, so just what I forgot to show just is what's quite useful, so it gives a differential diagnosis here, but you can now go in and have a look at more signs and symptoms. And then it will actually give you a comprehensive list of all the symptoms and signs that may be applicable. And I also like the descriptions that it gives with symptoms and signs. Sometimes one is not, well, let me rather put it this way, that, different clinicians do not always agree on terminology. So the fact that you have these descriptions is quite useful. And then also very important is that you can get additional information about the disease by clicking on it. And I think this is very, very useful. So it gives you some clinical information, epidemiological information, and so on, genetic information. Of course, not all the information on all the diseases is always already entered into the database, or it may not be available, and so on. Very useful, I find, is the fact that you can get the ICD-10 and ICD-11 codes for the diseases, and I think it's important that we start to report on that. And then important, the availability of clinical trials and then also treatments. So, for example, in this case, there is actually a company that provides enzyme replacement therapy for alpha-monoacidosis. So, and sometimes, even though these therapies are expensive, we've managed to get some patients on compassionate programs, not alpha-monoacidosis, but other lysosomal storage disorders. And in some instances, we've managed to get the medical aids to pay for it. So, we shouldn't just give up because it's a rare disease and there's a treatment that doesn't seem to be available. And then there's all sorts of other information that you can get. Patient societies, I think, particularly if you deal with an ultra rare disease, to have access to know at least, of the different centers of excellence, and who you could potentially contact there is quite useful to gather additional information in case Chris Hendricks is not available, so you have an additional resource. So yeah, I do find this quite helpful, and I thought it's important to share that with the audience as well.
So I just wanted to say that I would suggest that if you haven't signed the Ngwe pledge yet, and if you haven't gone on the Ngwe website, please do so. We added the link in the chat box there. You can't sign up. You need to sign the pledge. But if you sign the pledge, you will receive newsletters, and we will, in these newsletters then indicate when this will be active on the website, and other resources as well. I also want to say that, Elmarie, this was a fantastic talk, and people would want to re-look at this talk again in future, definitely, if you get to a point where you're having issues and you need to access these resources. So for this reason, we will upload this talk to our YouTube channel. It's also pasted there in the chat box, National Metabolomics Platform YouTube channel. So please like and share, and I don't know what you do with YouTube channels, but like and subscribe or something like that. Please do that. Yes, then we still have 3 minutes left. There's a hand from Chris Foster, and Dick, you are unmuted and unrevealed.
So I actually have a question for Dick.
Yeah.
Yes.
What I think would be incredibly useful, I often find this is a shortcoming in many of these online tools, is the option to actually indicate that the particular feature is not there. To be very specific, to say, there is no splenomegaly.
Right.
I think that would be useful in these tools. So what is the possibility of including such a feature?
It's a good, first of all, a compliment to all the people that made the presentations. I really enjoyed it. The feature is not in there because I think it has somewhat of a negative impact on the accuracy of the total prediction in the process, because we have weighted every sign and symptom relative to each disease. Now, my question is, how are we going to weight a non-existing feature in the algorithms? So it's more a technical thing than that we don't want to do it. We want to do it, but the question is, give us support how we can best implement such a feature in the portal.
Okay, I get you. It is a difficult.
No, we want to do it right. I don't care if it's difficult. We want to do it right. So that's the only thing.
Okay, so Dr. Elna Conradi also just asked me to remind everyone that if you're a clinician, even if you're in the state sector in South Africa, please apply for treatment for your patients. Even if there's a very small chance that it will be approved, it goes into a system and it will be documented and it will show the need for this type of treatment later on. So please, if you have a patient with a rare disease, please apply for treatment. And if you don't know the channels, you can contact us and we can assist you with that as well. You can just contact us on our website. Prof. Chris Hendricks, you still have your hand up?
Yeah, just quickly a comment there. Yeah, it's just purely to say that please do put these applications in, because one of the lifetime goals I have is that we need to get rare disease drugs funded to GDP per capita. And unless we have an insight of what is needed in what countries, we can't build the models. So don't give up hope. Do get them in, because that gives us the information that we can also know which treatment is needed and how do we get them priced, that everybody can afford them, including the state patients.
We have another comment there in the chat from Bertram Henderson saying the original LMD had a place to mark one feature as specifically being absent. I don't know if it's a comment or a question, but it says the original LMD had a place where you could specifically add a feature that is absent. That's just a comment. And another question.
I think the thing about
People are asking a lot of questions now. Sorry, Chris, continue.
I think the thing about having a feature that is absent is that it's dangerous if you apply it in a strict sense. So you may exclude the disease that you're interested from your differential completely by selecting something as absent, but provided that the user understands the implications, then it is quite, I found it useful in the past. There used to be another program that has been discontinued that also had a feature like this, where you could specifically say, exclude all diseases that has splenomegaly. But, the implementation of that to some extent, I do think is a little bit dangerous.
Okay. So there's another.
I appreciate the comment. I would like to evaluate what the options are. So thanks for bringing it up. It's a good point.
Okay. We have another question from Sibuyiswe Mpondo. Is it possible to use any of the resources to put in genetic results that revealed mutations of unknown clinical significance with clinical features that can assist with getting a diagnosis?
I don't think so. Nepro, you agree? Not with the ones that we discussed.
Not in the ones that we've discussed, but you should look at Franklin, where you can enter variants along with clinical features. Again, using phenotypic data with genetic data where your reference is just one case where the phenotype may not necessarily be due to the genotype that was found, is again risky, but it is useful. So just check out Franklin. I'll also put a link just in the chat section.
Thank you. I think we are 2 minutes over time. It's always good if we go over time, then it shows the audience is participating and they are interested in the topic. Thank you so much, Elmarie, for your presentation. It was really, really great. As I said, if you want to revisit this, please go to the YouTube. You're always welcome to share the YouTube video with your colleagues who couldn't make it tonight. Thank you, Chris, for your co-presentation, although you had to be bought with a chocolate. Thank you, Prof. Chris Hendricks, for your interesting contributions always. And Dick, thank you for joining us today. I think you're in a lucky position there because I see the sun is still shining and we are all going to bed now. So enjoy your day. Chris Foster just added the Franklin link there in the chat. Yes, and that's it. That's a wrap. Thank you, everyone. And thank you again for Pfizer for sponsoring this. I see we have a few Pfizer representatives in the audience tonight. Thank you also for joining. Okay, enjoy your evening. Thank you very much.
Bye.
Bye-bye.